Nandini. Here we are discussing about the introduction to process in memory. In this part, we are discussing about define a process and its importance in an operating system, and explain the basic concept and structure of a process in memory. And here we are discussing about the definition, an entity that symbolizes the fundamental into work unit to be implemented in the system is called process. A process is an instance of a program that is running in an operating system. It is a fundamental task that the operating system can plan and carry out. Here, one of the example you can see that consider an office setting where several projects are being managed currently. Similarly to a process, every project has a lifespan, many teams, and a project manager like processor management system who oversees all the activities, similar to how a project manager makes sure that every project moves forward smoothly. An operating system process management department makes sure that every process is carried out effectively. And importance of process management in operating system, here we can see that effective resource utilization, it permits the best possible use of system resources, guaranteeing that every process has access to sufficient resources without going beyond the system capacity. And next thing is system stability. It keeps the system balanced by the avoiding conflicts between the processor and making sure the resources and distributed fairly. Enhance productivity. Applications function smoothly when the resources are allocated and reallocated in a methodical manner, which raises a system overall efficiency and better user experience. It offers a responsive and stable system which improves user experience. And next thing, basic concept and structure of a process in memory. And text or programming code, the command that is produced will carry out. And data, it means the information used by the process to carry out its operation. And stack, functions, parameters, and return addresses are examples of the type of temporary data that are stored in the data structure called a stack. Heap, a data structure used to hold memory that is dynamically allocated. Process control block. A data structure called process control block holds details about a process, including its priority, memory utilization, and status. Here you can see the process in memory diagram, stack and heap, data and text. Next thing is process state. In this process there you can see the some of the processes and stages. You can see new, ready, running, and waiting and terminated. In new, the process is still being developed, and ready, the process is fully operational with all necessary resources at its disposal. However, the CPU is not executing instructions for the process at this time. Running. The instructions for the process are being processed by the CPU. Waiting. The process is unable to operate at the time because it is waiting the availability of a resources or occurrence of a event. This process might be waiting for something to happen like time going offer or child process finishing a disk access request keyboard and terminated. This procedure is over. And here you can see the picture of the process state and new ready. Every stage you can see that the arrow marks. And next one is process control blocks. The following process specific data are stored in the process control blocks or PCBs for each process. Different system may have different specifics. Process state, as already said, running, waiting, and etc. Process IDs as well as process. The programming counter and CPU register must be represented and restored when transferring process in and out of the CPU. Information on CPU schedule, such as scheduling quick points and priority information, and memory management information. Page tables and segment tables are examples of the memory management information. Accounting data includes account IDs, limits, and amount of CPU time used by the users and kernel. IO state details, open file tables, devices assigned, etc. Here you can see the process control block diagram and process state, and next thing the process number, program counter, and register, memory limit, and list of open files.